In this video, I'll be going over how to use trigonometric identities. So first, what are trigonometric identities? They are essentially equations that can be substituted for trigonometric functions. And trigonometric functions are like sine theta, cosine theta, and tangent theta. And so they're used to substitute for those functions and simplify expressions. But first, the formulas. Our formulas will be reciprocal identities, quotient identities, Pythagorean identities, cofunction identities, and even odd identities. But we'll be mainly focusing on the first three. So reciprocal identities, we have sine theta equals 1 over cosecant theta, cosine theta equals 1 over secant theta, and tangent theta equals 1 over cotangent theta, along with their opposites, which is found by multiplying both sides by sine theta, for this one at least, and then dividing both sides by cosecant theta. And you would do the same thing for secant theta and cotangent theta. Then we have our quotient identities. Tangent theta equals sine theta over cosine theta, and cotangent theta equals cosine theta over sine theta. Our Pythagorean identity, sine squared theta plus cosine squared theta equals 1. Tangent squared theta plus 1 equals secant squared theta, and cotangent squared theta plus 1 equals cosecant squared theta. So we'll be using these three formulas for our examples. So our first example, simplify the trigonometric expression sine theta over cosine theta plus tangent theta. So how would we simplify this? We would want to get the sine theta over cosine theta plus tangent theta into one term. So if we look back at our identities, we'll notice from our quotient identities, tangent theta equals sine theta over cosine theta. This means that we could take our quotient identity and substitute it here for sine theta over cosine theta. And so if we substitute it, we're left with tangent theta plus tangent theta, and that's going to equal 2 tangent theta. Oh, oops. 2 tangent theta. There we go. And so that's a very simple expression, an example of how you could simplify trigonometric expression. So let's look at something a little more complicated. Number 2. Prove that cosine theta over cosecant theta times cotangent theta plus 1 minus sine squared theta minus cosine theta times tangent squared theta plus 1 equals 1 minus secant theta. So what is the first thing we want to do? First, we would want to break up our expression into something that's a little easier to analyze. So first we're going to break up cosine theta, or decompose cosine theta over cosecant theta times cotangent theta into 1 over cosecant theta times cosine theta over cotangent theta. This is still the same as cosine theta over cosecant theta times cotangent theta. If you took 1 over cosecant theta and multiplied it by cosine theta over cotangent theta, you would still get this product. We just broke it up so it's easier to see. So now that we've decomposed this fraction, it'll be easier for us to find our identities. And I can already see that 1 over cosecant theta is going to be a reciprocal identity. And that reciprocal identity would be this. Sine theta equals 1 over cosecant theta. So using that, we could substitute 1 over cosecant theta for sine theta, and we'll have sine theta times cosine theta over cotangent theta plus 1. And this right here, cosine theta over cotangent theta, this is going to simplify into sine theta, as you can see. But what identity would we be using? Well, we would use our quotient identity, although you'll notice here that we don't have any quotient identity that directly simplifies to sine theta. And so that's why we'll be using cotangent theta equals cosine theta over sine theta, and instead setting it equal to sine theta. So what exactly do I mean by that? Well, we'll be taking this equation and first we would want to multiply both sides by sine theta. Sine theta. So we'd multiply this side by sine theta, and we multiply this side by sine theta. So that means sine theta is going to cancel out and leave us with cosine theta. And this is just going to leave us with sine theta times cotangent theta. But we want this to be, we want sine theta to be isolated. So what we want to do is divide both sides by cotangent theta now. So I'll just divide cosine theta by cotangent theta. And so when we divide sine theta times cotangent theta divided by cotangent theta again, cotangent theta will cancel out, leaving us with just sine theta. And so we have sine theta equals cosine theta over cotangent theta. So cosine theta over cotangent theta, if we go back to our equation, we'll see that's right here, cosine theta over cotangent theta. And so we would just substitute that with our quotient identity for sine theta. And now we're left with sine theta times sine theta plus 1 minus sine squared theta. Sine theta times sine theta, that simplifies to sine squared theta. And rearranging the question, is now sine squared theta minus sine squared theta plus 1. Sine squared theta minus sine squared theta, that equals 0. And now we're just left with 1. So now our expression is 1 minus cosine theta times tangent squared theta plus 1 equals 1 minus secant theta. So the next identity we'd want to use is going to change tangent squared theta plus 1. And that identity would be our Pythagorean identities. You'll see tangent squared theta plus 1 is equal to secant squared theta. So we'll substitute secant squared theta for tangent squared theta plus 1. And that's going to leave us with 1 minus cosine theta times secant squared theta. So for cosine theta, we also know with our reciprocal identities that this is equal to 1 over secant theta. So we'll use our reciprocal identities to substitute cosine theta for 1 over secant theta. And now we have 1 over secant theta times secant squared theta over 1. And if you multiply those together, you get the product secant squared theta over secant theta, which is the same as secant theta times secant theta divided by secant theta. So secant theta cancels with the squared, leaving you with 1 minus secant theta equals 1 minus secant theta. And that's true. And so that means that cosine theta over cosecant theta times cotangent theta plus 1 minus sine squared theta minus cosine theta times tangent squared theta plus 1 does equal 1 minus secant theta. And so that's how you would use trigonometric identities to simplify this expression, and in this case, prove that it's true. Besides that, something to note would be that once you start changing one side of an equation, you can't change the other side. So yeah, once you start changing one side of an equation, you can't change the other side. So in this case, since I started changing the left side, making 1 cosecant theta and cosine theta over cotangent theta to sine theta and whatnot, I can't change the right side as well to make it match somehow. I can't change secant theta when I've already started changing the left side. Well, besides that, that's basically how you would use trigonometric identities to simplify or to prove an equation is either true or false.